Hi, in this series of video, I'm going to explain about quantum computing. In this video, I'm going to explain about what is a qubit. So what is a qubit? A qubit is a vector. We denote the qubit as the following notation. This bar and bracket is called ket. Usually we denote a qubit as a ket psi, and it is a linear combination of ket 0 and ket 1, where coefficients of ket 0 and ket 1 are denoted as alpha and beta respectively. More importantly, these coefficients alpha and beta are complex numbers. So what is it mean to be a vector? So it means that there is two operations called vector addition and scalar multiplication. Vector addition means that if you have two qubits, you can add them together pairwise. So if you have alpha 0, 0 ket plus beta 0, 1 ket for psi 0, and alpha 1 ket 0, beta 1 ket 1 for psi 1, then ket psi 0 plus ket psi 1 equals to ket 0 plus ket 1 with the coefficient alpha 0 plus alpha 1 and beta 0 plus beta 1 respectively. Another vector operation is called scalar multiplication, and this means that you can multiply a qubit with any complex number, in this case lambda, so that coefficients of ket 0 and ket 1 becomes lambda alpha and lambda beta. So how do we represent a qubit? There are several ways to represent a qubit. One way is using matrix. More specifically, we will use n times 1 matrix to represent a qubit. For example, you can represent a single qubit with 2 by 1 matrix with complex entries. Alpha, beta, which are coefficients of ket 0 and ket 1, becomes the entry of 1, 1 and 2, 1 in 2 by 1 matrix. So another question is, how do we represent multiple qubits? So multiple qubits can be represented by tensor. This is how we denote a tensor. So for example, let's say we have two qubits whose quantum information is stored and represented as psi 0 ket and psi 1 ket. And let's say we take the tensor product to represent two qubit state. I can rewrite each ket state as 2 by 1 matrix, and the tensor product between 2 by 1 matrices becomes 4 by 1 matrix, where each entries are simple multiplication of the entries of each matrices. For example, if you look at the first entry of the 4 by 1 matrix, it's alpha 0, alpha 1, which comes from the multiplication of the first entries of two 2 by 1 matrices in the tensor product. So let's talk about a little bit easier way to represent multiple qubits. Multiple qubits can be represented by numbers. For example, if you have 0 ket tensor with 0 ket, you can simply put these two zeros together to call it ket 0, 0. As I mentioned before, every quantum state is a linear combination of ket 0 and ket 1, so there are only 0 and 1. So you can take a tensor product of 0 ket and 1 ket and amalgamate them together to make a binary digits. So once you have a binary digits, you can represent those digits as a natural number. So 0, 0 becomes 0, 0, 1 becomes 1, 1, 0 becomes 2, and 1, 1 becomes 3. So you can write natural number inside the ket notation to mean exactly what you mean by the tensor product. However, when you do that, you have to put the number of qubits as a subscript to indicate how many tensors are there. Here, since we took tensor of 2 qubits, we put 2 as a subscript below the ket of natural numbers. So in this video, we talk about what is a qubit. In the next video, we're going to talk about what is entanglement. Thank you.